All right, hey everybody. Today we're going to do a lesson on Pangea and continental drift. So the continental drift theory was kind of the first theory in this greater theory called plate tectonics. Plate tectonics is kind of like a stepping stone theory. What I mean by that is it started very simple with this idea called continental drift. Then it went to this evidence of seafloor spreading, and then it combined all of them into this overall theory called plate tectonics. So I attached these notes on your Google Classroom. So while I'm playing this video, make sure you open those up. Okay. And on your slides, a lot of them are blank. And on my slides, the notes are filled in. So as I present this and I go over the notes, you should copy what you either read or things that I am saying. Okay. So let me press present. All right. So here we have the first slide of your presentation, which says Pangea and continental drift. The word pan means whole, and Gea means earth. So Pangea literally means whole earth, and it's the name given to this supercontinent that once spanned really half of Earth, I guess, because there were no other large land masses around at the time. There were other chunks of land masses, but none that were huge and identified as their own continents. So all the continents were once together as this giant continent that we call a supercontinent called Pangea. And pan means earth. Sorry, pan means whole. Gea means earth. And pan, you'll see in other words like Panama. Panama, the country, means it crosses or connects both Americas. All right, it used to be an airline called Pan American Airlines. So the airline would connect or cross the Americas. So connecting or whole, that's what pan means. So this theory was first given the most evidence by a man named Alfred Wegener. Now, Alfred Wegener came up with his idea really just by looking at the shapes of the continents. So if you click on the link, it will take you to this site. So if you look at the continents, so on the world maps, when they were being made during Alfred Wegener's time, people, not just Alfred Wegener, people realized, look here, that South America, the east coast of South America, fit with the west coast of Africa like two giant puzzle pieces. That this might have been connected to here. Okay? Now, a lot of people just thought it was a coincidence, but not Alfred Wegener. He said, I actually think they were connected. He also looked here. If you look at North America, see this shape right here? Look at that. That looks like North Africa. Okay? So this part of North America would have sat right here on Africa. And this part of South America, which really looks like it fits well, right into this kind of corner or elbow area of Africa. So Alfred Wegener noticed that, and so did a lot of other people. But the reason why he's given the credit for coming up with the theory is that he went out to help provide evidence to support the theory. And he wrote a book as well. And he also called the supercontinent Pangea. So he said, you know what? I don't think they were just connected. I'm going to go out and try to give evidence. So if they were really connected, what would be some of the evidence he would look for? Well, if this really was touching that, then we should find identical fossils of plants and animals that couldn't cross a large ocean. Because you don't want to look for fossils of things that can swim really well, because then you could just say, well, they weren't connected. That creature just swam across. Or if it was a seed that wind could carry far, or a seed that would float, you'd be like, well, that's not good evidence because the ocean current could have carried the seeds. Or maybe the birds carried the seeds. So you wanted to look for certain plant fossils and animal fossils in which we knew there was no way that these creatures could have crossed a large ocean. And he found these things. And we're going to do a lab and learn more about these different fossils that he found. And so he found identical fossils here that matched here. And same thing, he found identical fossils here in North Africa that matched here and all around the world. Right? And that helped him put his puzzle together. The other thing he looked for was matching rocks. So if this area of South America was really touching this area of Africa, then these rocks should be identical to those rocks. All right? And so should what's called the landforms, like the mountains and the valleys, okay, and the plateaus. So if we find a mountain range here, which we do, the Appalachians, okay, it's an ancient mountain range. It's close to us in the Northeast, so hopefully you've heard of the Appalachians. And the Appalachians are identical to the mountain range here that goes through the country of Morocco called the Atlas Mountains. So that means we were once connected, here's New York, with Morocco. That's pretty cool. All right. What I'm going to do right now is play an animation showing you Pangea together and then the separation. Okay. All right. Maybe not. Okay. Here we go. So that's when it was all together. Let me pause. So here's South America. See that? Here's Africa. Here's North America. So here is where New York would be, right there. And that's North Africa. That would be where the country of like Morocco is. Okay? So right now they're all connected. And here's Spain, and the rest of Europe, and Asia kind of hasn't really taken the form you recognize today. Here's India. Down here's Antarctica. Down here's Australia, and down here's Antarctica. And we're going to do a lab on this, in which you're actually going to cut out the pieces of the continents and try to make this Pangea, this supercontinent, on your own. Of course, you'll have clues to do it. So let's watch it separate. So here it goes. Let me pause it right here. If you look, North America has separated from Africa first. Okay? And if you know your geography, what's between North America and Africa? The Atlantic Ocean. And if you look at a world map, the Atlantic Ocean is a lot wider north of the equator. So north of the equator, North America and Africa and Europe are far apart. And then below the equator, South America and Africa are closer together. And the theory behind that is that North America separated from Africa first. I like to think of it like unzipping a jacket. So we think the Atlantic Ocean spread or grew from the north on down, kind of like unzipping a jacket. If I unzip a jacket, the top separates first, and the bottom, the southern portion, is closer together. So we kind of think the Atlantic Ocean unzipped or spread that way. So watch, see, Atlantic Ocean's growing. See, North America is already pretty far from Africa. And here's South America. It's just starting to separate. Europe's starting to take shape. Here is Italy and the Greek islands and the rest of the Balkans, which is starting to move up north to collide with Europe. And India is an island here. So let's keep on playing. All right. So now North America really has taken its shape. Europe is starting to take its shape. So is Asia, but it still looks really incomplete because India is an island. Okay. And the Middle East is over here. So the Middle East hasn't separated from Africa yet and collided with Asia. So really, we haven't had a parting of the Red Sea. Hey, Passover just ended. Look at that. So the Red Sea is actually the youngest ocean basin. It is just opened up recently. So the parting or the widening of the Red Sea is just not a biblical story. It's also a geological event. And it's a very young ocean. So watch this. See, India is going to collide. And when India collided with Asia, it formed the world's largest mountain range called the Himalayas. So what happened is India was on a head-on collision with Asia. They hit, and it was kind of crumple zone. All right, and that's how you get really tall mountains. When two pieces of the continent collide, they have nowhere else to go but up. Okay, and that's how mountains form. All right, you could play this and slow it down, and hopefully you know your geography. I just mentioned it a lot because I don't know how strong you guys are. And here we go. Here's that last part with the Middle East. And there you go. There's your Red Sea. So you could play this over and over again. Okay? Those that are really paying attention to this, you might notice there's yellow. The yellow is our current coastline. And then there's a lighter blue and then a darker blue. The darker blue is really where the oceans begin. And the lighter blue is called the continental shelf. It's where part of our continent is flooded. Right? It's still considered the continent. And that's why they have those different colors there. Okay? So back to the notes. So that's what these pictures are showing, this little slideshow. So this is 250 million years ago, Pangea formed. Then the northern part separated first, and we called the northern part Laurasia. It's kind of got the word Asia in there. And then the southern part, Africa here, South America, Antarctica, India, and Australia, they called that huge continent Gondwanaland. All right. And then here, so it goes from this picture to this one, then to this one. Okay. Then to this one. And now present day. Okay. All right. So if you wanted to watch the animation, you just click on the link. All right, next slide. So these are blank. Some of these, like what's in blue on yours, so please fill them in. So the continental drift is the theory that states that all the continents were once joined in a single supercontinent called Pangea. And the continents are slowly drifting apart. I want you to add down, they're still moving today. Okay? Which means the Atlantic Ocean is getting wider every day. Well, if that's true, what ocean then must be shrinking? The Pacific. And if you know a little bit about what goes on in the world, guess where guess where most of the world's earthquakes and volcanoes are located? They're located around the Pacific Ocean. We get very few earthquakes and volcanoes in the Atlantic, right? New York's on the Atlantic. We're not concerned about earthquakes, but California is, all right? And earthquakes can make tsunamis, okay? Japan's on the Pacific. Tsunami is actually a Japanese word, but we don't really hear about tsunamis in the Atlantic, all right? Add down Alfred Wegener. He's the man that came up with this theory. Next one. So now this part's blank on your notes. So these were his major evidence. Number one, the jigsaw fit of the continents. So that's basically saying the continents or the coastlines of distant continents fit together like a puzzle. And this is the lab we're going to do this week. Okay, next. He looked to match fossils. So matching fossils of extinct organisms means plants or animals or anything, okay, that was once alive, that couldn't cross the ocean are found on separated coastlines. So these were the fossils remains. So this creature right here, does that thing look like it could swim well? No way. Okay. And this thing too. So this creature right here was found in this area of Africa and that area of South America. But how's that possible if it couldn't swim? Well, that means their continents must have been closer together. Okay. 3, matching rocks and minerals. So if I find a specific like gold deposit, let's say I find a gold deposit in this area of Africa, then I should find matching gold deposits on this side of South America. And that's actually what miners do. They'll say, hey, if there's gold on this coastline, and if the theory of continental drift is true, then let's look for gold on the other coastline where it matches. Right? And usually they're right, and they'll find it. Okay. Matching mountains. So here's the Appalachians. This is if you don't know what you're looking at here, this is Florida. Here's Long Island right there. So this is the Appalachian Mountains. Okay. And this is the Atlas Mountains. And there's also matching mountains in Scotland, in Scandinavian countries up here, okay? And even parts of Greenland. These are all the same mountain ranges. And climate evidence. That might be the hardest one to understand. So, like Antarctica, if you know where Antarctica is, it straddles the South Pole. So Antarctica is extremely cold. But when we went to visit Antarctica, we discovered coal in Antarctica. We know that coal can only form in tropical, swampy areas. Tropical and swampy. Well, right now, Antarctica is covered by a giant glacier, which means Antarctica must have been much warmer at one time. So you can either conclude two things. Earth was much warmer, or Antarctica was once closer to the equator, therefore it drifted. So climate evidence also helps to support the continental drift theory. We also find glacial evidence, not current glaciers, in Africa. Well, Africa, pretty much the entire continent is tropical, which means hot. So glaciers cannot form today. But we find matching glacial evidence where Africa would have met with South America. So basically this is saying places that were once cold are now warm, okay? And places that were once warm are now cold, all right? Which tells us that either Earth really changed in climate, which is definitely possible, or those continents moved in latitude to either warmer regions or colder regions, okay? And then the last thing, which you need to copy as well, why wasn't Alfred Wegener's theory on continental drift initially accepted? So when Wegener came up with his theory, a lot of people said, okay, good job, Mr. Wegener. You did a lot of research, you wrote a good book. But then they asked him the question, okay, how did they move? And he had no answer, okay? So if he was asked how they moved, he had no answer, which means he could not come up with a force that can move continents. So he knew or had the evidence to say that, hey, these were connected. And most people just said, that's just a coincidence. We don't think they were connected. What's moving them? What's the driving force? What will be able to push or pull continents? And he had no answer. Okay, so copy that last part down. That's it for today's lesson. We'll have another one on continental drift this week. We're going to do a lab on it as well and some readings. All right, have a great day.